Hello, it's Paxton. I'm back. I got another video. And before we get started, I want to point out that the FN spawn player, or player spawn, whatever it was called, I've changed the name of it to FN underscore test scripts. Not only did I change the name of the file, also went into Description.ext, and I went to our functions.hpp and change the class name to test scripts. If you forget that step, it won't work. Alright, I've done a little bit of work with my microphone. Hopefully it's better, but I'm working with what I got. And if you notice, I'm using a different editor. I'm using Visual Studio Code. I'm liking it. It's got a great SQF plugin, and it also has Git support, which I like. IntelliJ had that as well. I haven't used it with this yet, but I'm looking forward to playing with that and seeing how easy it is to use. If you do download the Microsoft Visual Studio Code, if you want to use the SQF plugin, all you have to do is hit Control P, type in EXT SQF plugin, hit enter, and then right here it's going to say install, and there you go. It only takes a second. Alright, and right before I get into scheduled and unscheduled environments, which is going to be the main focus of this video, I'm also going to throw in a little FYI. In the past, I've been initializing variables for parameters that are passed in with this select 0, because the init player local.sqf gives you two parameters, the player and the boolean, the object and the boolean. The object's the player, the boolean is it join in progress or is it not, so it's true or false. So in the past, this is how I have done it. I showed you this way to keep things simple, but now I'm going to show you a newer way, and it's supposed to be more optimized. And some of them also, and they do also give you more options than just defining the variable. So I've shown you this, and I've also shown you to make these variables private for this scope to avoid conflicting with other scopes. You do this here, unit, and then you also do is JIP. So then this makes this unit here private and this one here. So you can take this completely out. You can add in the private keyword here and here. That now makes them private. And instead of this select 0, we're going to use, just for a second before I show you something else, we're going to use param 0. And for is JIP param 1. That does the exact same thing, but param also gives you some other options. You can have a default value if param 0 or the select 0 is undefined or some sort of error. You can have a default value for it to fall on. You can have true for that, or just this is defaults. Then you can also specify the data type, like we're expecting an object. So I believe that's how you do it. If it was an array, you would do an array. If it could be more than an array, if it could be a number or whatever, or string, you do that there. And for this one down here, it would be a bool boolean or bool. I'm not sure how Arma does it, but you can look and see. And then assuming that this is not an array, you just do one. This is the expected elements in the parameter if it was an array that's being passed in. We're only expecting one. So those are more options param gives you, and you can just take out one if you don't want it, take out that one if you don't want it, take out that one. But if you want to use the last one, you have to use all of them. But if you just want to use the first one, that's fine too. Now, there's another way, and that is with params. Oops. Now this is similar to that private command that we were using a second ago, but it doesn't just make this private, it also defines it. It's going to take the first element coming in for the parameters and assign it to the variable name unit and make it private if I didn't say that already. Same thing as GIP. I mean, obviously you can name these whatever you want. These are just names I'm naming them. You can do whatever you want, and that's still going to work. But keep in mind the length of the variable has an effect on the performance of the script. So the shorter the better, as long as you can read it. And if you don't care about reading it and you just want the best performance, you can just make them really short. Other language, I don't think that's as big of a deal, but I have noticed a lot of performance difference in really short variables and long variable names. It definitely has an impact on the speed. So now we already have unit available, we have this JIP available, and if you wanted to the added functionality of the param command I showed you, you just add an array into here, and then you have it. Why is it not creating one? There. So then you would just do the same thing here. Oops, if I could type, and just so on and so forth for each variable. But we're just going to use this. So there's a little quick run through on different ways of getting parameters that are being passed to you. You can do that in this file, the init player, the init server, init, all those, and then for the functions you create, you can do the same thing to retrieve the parameters that you are passing in. So we're going to get into scheduled and unscheduled environments, and we're going to just focus on two different ways. How am I wording this? We're just going to focus on functions at this time. We're not going to look at scripts, like files and all that, because there you compile and you spawn, or you compile them. You can call them. But today we're just going to what just happened? Some autocomplete here. We're just going to focus on call and spawn. Now both of these they do the same thing in different ways. When you call a function, say we're going to take our player and we're going to call our test script function. That takes the player parameter, passes it to our test scripts. Now, let's do player spawn. Alright, now I guess the plugin has a little bug in it there, I guess. Who knows? But spawn does the same thing. It takes player and it passes that into the functions, our function there. But one is scheduled and one is unscheduled. Spawn is scheduled, meaning that it's going to go into a queue. And depending on how many stuff's in the queue, could change how quickly this executes. It will work on it a little bit and then go through each script that's in the queue until they're all completed. Call will not do that. Call is going to run this function until it's done and then continue with something else that is unscheduled. It's not in the queue. With that being said, any functions that you call, it means that they cannot suspend, which means they cannot have sleep, UI sleep, wait until. They can't have anything like that. That will cause the script to suspend its execution. It's got to be able to go right through it. Loops are fine and all that, but it cannot sleep. Spawn, however, can. If you want to have sleeps, UI sleeps, wait untils, you need to spawn it, because it'll put it in the queue, so while it's waiting for the sleep or the wait until to complete, it can continue on working on other scripts. So with this, let's hint call has completed. Let's take out the spawn. Let's just say script completed. And let's go to our test scripts. Let's get our parameter that we are passing in. Oops, this actually is the player, but I'm using unit. Whatever. And let's get the position of our unit. Then let's create a cube. Hopefully I still have it on the clipboard. Oh yeah, there it is. That's our cube we're using. And to create that, we're going to call the create vehicle function, and it's going to be on the player position, which is going to put them. It's going to not put it directly on the player position. It's going to put it really close to it. And we do not want physics on this cube, so we're going to use the enable simulation and set that to false. Then after that, let's take the cube again. Let's set position at sea level, and any position is an array. So we want to break down this position of the player. We don't want to just use the whole array of POS. We want to break it down so that we can have access to the different elements of it. So we want to take position. We want to select 0, which would be the X coordinate, and place it likewise. And we're going to do the same for each element in this array. There you have it. Let's make this a little easier to read. Alright, there we go. We have our X. Oops. We have our X, Y, and then the Z, which is up and down. And we want more of these. What we're going to do Let's create a for loop. Actually, yeah, let's go ahead and create a for loop. And our increment variable is going to be underscore I. So for I from 0 to, let's do, I don't want to do it too long. I don't want to do it too short either. Let's do 10,000 to start with. We need to crank it up as well. Oops, that is where I wanted it. So from 0 to 10,000, it's going to execute all of this code. And we want to take the y and we want to add 1 meter to each time it iterates through it, creating a new block. So we're creating a cube 10,000 times, and we're setting its position. We're setting it initially at the player's position, then we're resetting it to the same x, the same y, plus the increment value, which is going to start at 0, and then 1, 2, all the way up to 10,000. And then we are going to change the height of our cube by our step value, which we haven't created yet. We're going to come up here outside the loop so we can initialize it, start it at 0. Oops. And down here, after we set the position, we're going to take step, and we're going to set it equal to itself plus 1. Alright, I don't know if I need to walk you back through that or not. I think I did a pretty good job. Hopefully you understand that. And let's get out of full screen. Let's launch our server. And we are calling the function. So we are putting it into an unscheduled environment, or keeping it in an unscheduled environment, and then we are going to hint that it's completed. Let's see if we get the server running. It's just about there. It should show up here. I was doing this in the editor, but it was executing stuff so fast that I couldn't really show what I wanted to show. I'm thinking that since I'm running 2 games practically here, I'm running dedicated server and the game, it takes a little longer to complete things. And I have an i5 4670K, which is a pretty good processor, so I mean, I don't know. Guess I could have better. Give this a second to start. After I show you the call, we will spawn it, and there's a couple things I want to show you, a couple more differences I want to show you, so that way you can handle your scripts and you know what's going on. Because if you don't understand it, you could get some bugs and you can't be chasing around trying to figure out what's wrong. Alright, undefined variable and position. Error, undefined variable and expression player, params unit. Wow, it just keeps on going, doesn't it? Let's see what I have done. I get my mouse back. No point in running the server. Params unit. Okay, that's the init player. Oh, I'm an idiot. So I've initialized this variable as unit, and then I've tried to pass a variable that has not been created into the function. And since I did that, the variable that I passed into here was not defined, so it took a position of undefined variable, which made that undefined, and so it just nuked the whole thing. So we'll save that. We now have correct parameters and variable names. That was a definite oversight. I have been using underscore player a lot, and then I kind of jumped to underscore unit, so I guess I'm confusing myself. Because you can use whatever you want, but whatever. Oops. Yeah, and I've been a couple different mission ideas I've been playing around with. Maybe I'll get one finished eventually. Get it running. Here we go. See what we got. And there is our stairway. That is not correct. It's going way up there, but I've made a mistake. How do I always make mistakes? Script completed. So we do need to crank this up. That did not take long enough. So when you're calling something, it's doing it in a unscheduled environment, which means it's going to complete this first before you run the hint. But obviously 50,000 or 10,000 was not high enough. Let's up that to 30,000, and then let's fix what I've done here. That's what it was. I do not want step to be 1 meter. I want step to be 0.25. If I was just doing 1, I could have used the I value there, which is not what I'm doing. So hopefully 30,000 takes a bit longer. That way you'll see that when you start the mission, you're not going to have this hint right away. It's going to take a minute for it to show up because it's still running through this call. And when I do something wrong, it takes a little bit longer for waiting all this stuff. I apologize. The editor just does it too fast. I was going to start doing stuff in the editor, so speed the process up, but with only one game running, it was just executing stuff way too fast. That just show you the difference in call and spawn would have been a little more difficult. I could explain it, but it's just need to do it this way. So maybe in other videos I will just work in the editor when we're not focusing on client and server relationships and scopes and public variables and add public variable event handlers and such. But I'm going to try to speed this up really fast so you get to see what I'm talking about. Alright, actually, you know what? The next time I start it, I'll explain a little bit about the Description.ext to you. I know someone mentioned that they wanted to understand that a little better. It's pretty simple. I'll show that to you here in a little bit after we run the call. Maybe while we're waiting for the spawn example to run, I will show you that. And the script has completed. That sucks. I definitely don't get to show you what I wanted to. But I do have my staircase here. So we're looping through the creation of these blocks we're doing it 30,000 times. And we're putting each block 1 meter further to the y coordinate of the original start position. So if you do the math, this staircase goes 30,000 meters. And then if you do the math, it goes up 1/4 of a meter 30,000 times. So that would be, the math's a little more difficult for me. 30,000, half would be 15,000, so half of that would be 7,500 meters. So this goes up close to 8,000 meters high. And it's going to take you 30,000 meters to get there, which I'm obviously not going to make you wait for me to run that far, because I don't even know what happens if you go that far. I've been really high up there into the skybox. It's really buggy once you get there above the sky. It's pretty cool though. But here's your staircase, if you ever wanted one for whatever reason. The grenade hits the ground before it blows up. And you can jump. And I died instantly. Alright, so enough of that. So doing 30,000 was not enough. We need to do 50,000. And I need to take the server down before I tried to do anything. Which I think I did. I had this problem earlier where I thought I took the server down, but I didn't take it down. Alright. I go ahead and stop the server. Alright, that should do it. Now at the init player. Now if this took longer, you want to install this script until it finished. Now it's at 50,000. It should take plenty long. But now if you change the call to a spawn, why is my server still running? Now, if we change the call to a spawn, what this does is going to create a new environment. It's going to start a new thread, and this function would be added to a queue, which will allow this script to continue running. So when it hits this hint here, the script or this function, or it's but test scripts. Test script's still running because we used spawn. But since we use spawn in test scripts, we are able to use functions such as sleep, UI sleep, and wait until. We're able to do all this stuff because we spawned it, and it's in a queue, so the scheduler will be able to handle it. If you try to use sleep or wait until in a function you call, you're going to get an error and it's not going to execute because those functions, it doesn't put them in the queue, so it's not able to sleep and then come back to it because it has to be able to continue to work on other things. It can't just halt all it's doing and wait for this one function to finish. But if you do have something that you need to sleep or whatever inside a call function, you can spawn a thread out. You can spawn a thread from that function, so that will put that part into the scheduler. Hopefully that makes sense. But with call, at the end, if you were calling this, at the end of your function, if you had a variable that you wanted to return, such as maybe you want to return the step variable, or you want to return true that it's completed, or stuff like that, you can get that with the var, or whatever you want to call it. I'm going to call it variable var, and that will return that value to here when this is finished. Now if you change this to spawn, you can no longer get that variable, but what you do get is a handle to this script. Like I said, once you spawn it, it's going to keep running this file. It's not going to wait for this to finish. But let's say you need it to finish before it continues with whatever function or however you had it, whatever you're doing in it. You need it to sleep, you need to wait in it, you have these things you need to do in it, and you don't want to create a new thread, but you want this script to wait till it finishes. You get this handle here, and then you can use wait until script done and put the handle in. So now your hint would then be script finished. But let's just do script not done, because I just want to show you. Actually, you know what? Let's really bog this down. Alright, so let's take unit, our function, and we're going to want this one to spawn because we want the game to keep running. So let's take this, and we want it to go up in the X direction. So X, let's just default X to 0. We'll call that 0. And then let's spawn another one. Let's call this handle 2. Let's do this 1. And then let's create, that one go that way, that one go that way. How would I do this? X, Y. I think I can figure this out. Let's have one go up that way. Let's have this handle 3. Let's change this to 2. We'll go here to functions. We added another parameter, and we're going to call this our direction. So we got our direction here, and this is probably going to slow it down a good bit. We're going to add a switch statement in here. Let's add a switch. Switch is going to be the direction variable. We're going to do let's leave the step out of it. Let's tab this over. It's a little more than I wanted to do. I was planning on doing, but this could be fun, so that's why I'm doing it. So let's add a case 0. I'm going to do this. Let's go ahead and copy and paste this. Case 0, case 1, and case 2. Case 1 and case 2. Now this is incrementing it on the Y So let's add this to our Y case. And the height is going to be the same. This is going to be our X. So we're going to cut this out like so. And then let's paste it. Oops. We want this here. And let's go backwards. I think that should work. So what we're doing here is we're passing in 0, 1, 2 inside our parameters here. And it's going to come down to the switch statement. Depending on what dir is, it's going to execute this through each for loop. So this is going to take a while. Let's bump this down to 10. That might mean too much. Let's dump it down to 3,000. And everything looks correct. Get my brackets right. Let's go ahead and launch this. And while this, actually I'm going to wait till the mission launches. We're going to look at the Description.ext. Which I don't think this one, what did I have this one? This is the basic, okay, this is the one that I had set up for you. We'll move into a little bit more involved one. Let's get this started while I'm poking around in here. Alright. Give me 1 second. I'm going to find a mission I already had that's got a pretty much made a Description.ext that has all the pretty much all the stuff in it that you can have as a reference. No, that's not what I wanted. I really need to clean out my file system. Let's go to one that I know it's in there. I know my Badlands mission's got it. Let's open this with our Visual Studio Code. Watch now, give me an option. That's the regular Visual Studios. There it is. And of course it's going to give me a new window. Why wouldn't it? Zoom in here. Alright, let's check our mission. But I didn't crash it. It may have crashed. Alright, with Description.ext you have a lot of stuff you can do. Starting with your author, all this stuff is self-explanatory. Some of them may not be, but with here the load screen you would have a .paa. I believe you can use JPEG as well. That's the screen that little picture that shows up when you join missions. Respawn base, we're already using that one. 0 is false and 1 is true in all these cases here. That's where they show them or not. -1 is going to result back to like a default behavior. And you got disable AI, which we already went over that one. And you can just go to the wiki, go to search Description.ext, and it will show you all of these, and it will explain a little bit about them. It's not really too difficult. These includes here. I showed you those in a previous video on defining your GUI. We've done CFG functions. You also have CFG sounds you can put in here. And there's a couple other ones I can't think of the top of my head. You have debriefings, you have briefings. There's certain things you can do with the loadouts and stuff like that inside the Description.ext. This pretty much defines the default behavior of the mission. Actually, just go ahead and watch this. I don't want to miss anything, any of the action here. Because I don't think we made it to the map yet. Hopefully you learned something from this, and it was nice and clear and understandable. If not, just let me know. And what did I do wrong? Oh, okay, there we go. There we go. It started at sea level, so the first initial ones you actually don't see. So there we go. And they're all working at, actually I think they're all done. But if we called each one, it would create this one, and then create this one, and then create this one. But since we spawned it, it'll work on all three at the same time. Kind of make up for, oh no! I survived. But yeah, this one's not that far. These are only 3,000. I think you can see the end of them down there. But anyway, that's it. And if you actually, before I go, that enable simulation false, if I set it to true, it wouldn't allow these blocks to be this close, and it may even allow them to fall down at some point. But you still have the collision. That's not necessarily physics. So I'm going to leave it at that. I hope you learned something. Comment below, subscribe, thumbs up, like, all the fun things. Let me know what you think, and I will catch you next time.